My name is Ryan Mongeau. I'm the Director of Technology for Space Age Electronics. Essentially what I'm responsible for at the end of the day is looking at the needs of the company today and into the next few years to figure out what we need to do or align ourselves with the demand that we're seeing. So that could be anything from new software, new computer systems, and in this case, different pieces of automation for manufacturing. So this is an Amada HGARS robotic bending cell. It's an automated machine that takes flat pieces of material and bends them into whatever the final product is. So traditional bending involves manual loading of tools, manual programming, and an operator physically putting parts into the press brake and forming them from the flat into whatever the final enclosure is. So what this machine does is it takes a stack of blanks that come, our automated blanking cells will stack them in a pile. And then this machine will use a camera to see where they're positioned on a pallet to pick the piece up and then bend it and stage it on the other end. So this one in particular, what we're expecting to see is anywhere from a 20 to 30% efficiency gain. And that's not necessarily in cycle time. It's more going to be because this can run longer unattended. So we can have an operator come and load it with material, and then the robot will just run unattended. It will keep picking parts up, it will keep bending them, and it will just keep stacking them on the other end. So it's going to allow us, when we get into the larger multiple hundreds into 1,000-piece runs, we can load it full of material and let the robot just go. So it can run basically from the beginning of the day when operators come in to even after they leave to just keep chunking away at it. So we get more production time out of it. We work very closely with Amada America. We've built a very close relationship with them over the past 10 years or so that we've really been working with them, from our first automation purchase, the EMK, to now this machine. So we've worked with them to source this machine from their manufacturing facility in Japan. They bring it here, and then we work close with their technical crew, their automation engineers, to actually build this machine. It's about a 4-week process, so just shy of a month, to uncrate it, put everything where it goes. It's a very precise job. If you look at it, there's a lot of pieces that are staged all over the place, but they're staged in a very precise way. Things, are within millimeters of each other, so that it's to an exacting standard. We've focused primarily on blanking. That was the biggest piece of automation that we wanted to start with. And I would say that we've really kind of rounded out that area of our manufacturing automation. So we then kind of got ourselves into bending automation. Our first robot was a way for us to kind of get our feet wet a little bit, because we hadn't really had much experience with that level of automation, and working that closely with a robot, and training it, how to pick up parts, how to bend them, how to stack them. And now that we've really kind of ironed out that process, we were ready to just go full in with this machine here. And looking forward into the future, it's now the only missing piece from that is how do you get the material from one machine to another? So there's all different kinds of options out there. You see Amazon's developing material handling robots, automated guided vehicles. So that's kind of the next thing that we're looking at down the road, is how do we get the entire process automated? We want to be able to load material into one machine, get a completed process, and then move the material from there to the next stage that will also be automated, which is kind of the goal of this addition to the facility, to be a completely automated production line.